So hope you have tried the two non-homogeneous equations in the practice question set of non-homogeneous equations, since I am going to discuss how to do those questions. So if you have done previously, it will be very effective for you to grasp how to take the solution of these equations. So we have this non-homogeneous equation here. First we need to make this into homogeneous. So we actually say that it's reduced to the homogeneous form. So when solving these non-homogeneous equations, first we have to reduce it to homogeneous form. So for that we take substitutions like let simple x equals capital X plus h and simple y equals capital Y plus k. So here h and k are constants. So by substituting x and y by x plus h and y plus k, we can reduce this equation to homogeneous form. So we'll do that. So here dy by dx equals y plus k minus x plus h plus 1 divided by y plus k plus x plus h minus 5. So here we get minus x plus y plus k minus h plus 1, x plus y plus k plus h minus 5. So here the condition is that these two should be equal to 0. So here k minus h plus 1 equals to 0, k plus h minus 5 equals to 0. So by these two equations we can solve for k and h. So we get, by adding those two, 2k equals 4, so we can get k equals 2 and we can get h equals 3. So we found the answers k and h, and now since these two are equal to 0, we get the equation as dy by dx equals minus x plus y over x plus y. So now this is in the form of an homogeneous equation. So we have learned how to solve homogeneous equations, and then we have to take the substitution y equals vx, where v equals y over x, dy by dx. So here actually it's dy by dx equals v plus x dv by dx. So now we have to substitute this with this, and we have to make these xy terms into v terms and simplify as we have done in the earlier sections. So moving on, v plus x dv by dx equals so we are dividing these terms by x, we get minus 1 plus v over 1 plus v. So by substituting by making this v into the other side, we can get minus 1 plus v minus v squared by 1 plus v. And now by separating the variables, we get 1 over x dx equals minus 1 plus v squared plus 1. So by solving this, by simplifying this, we get this. So now we can easily take the integral of both sides. Here we get ln x equals minus and the integral of this. So to take the integral of this, we can take partial fractions, or we can take another substitution. So we'll take, let u equals v squared plus 1, then du equals 2v dv. So by substituting this to this, we get integral v by u du by 2v equals integral 1 over 2u du, and then we get ln u by 2, which is ln v squared plus 1 by 2. So which is, this is equal to v squared, v over v squared plus 1. So here now we can write ln x equals to minus 1 over v squared plus 1 dv minus v over v squared plus 1 dv, and we get ln x equals, so for this 1 over v squared plus 1, we have an integral tan inverse v, minus for this we have this ln v squared plus 1 over 2 plus c, where c is an arbitrary constant. So we can substitute for v y over x. So here we get tan inverse y over x. So here we have minus sign here, and minus here we have ln y over x squared plus 1 over 2 plus c. So this is the equation. Here we have substituted here actually capital Y. So make sure you don't make any mistake when substituting those. So now we have the expression in capital Y and Z forms. So here it should be capital X. So here the V is back substituted with the capital Y and capital X. Now again we have to substitute into the original form, which is simple Y and simple X. So capital X, we got capital X here. From this equation we can take capital X equals simple X minus 3 and capital Y equals simple Y minus 2. So substituting this in the equation, we get x minus 3 equals minus tan inverse y minus 2 over x minus 3 minus ln y minus 2 over x minus 3 whole thing squared plus 1 over 2 plus c. So this can be kept as the final solution in the implicit form. So this is how we solve the non-homogeneous equation. First of all, we need to reduce it to the homogeneous form by using the substitution for simple x and simple x and simple y by capital X and capital Y. And then we need to find those constants k and h, and then we get this type of an equation which is homogeneous. And then we have to take another substitution, which is y equals vx, where we have done it before in the homogeneous equation solving methods. And then by differentiating that, we get this, and we get an separable form like this. So and then we have the obstacle of solving these integrals. So we have to master integrals as well to solve these ODEs. And here for solving this, I took an substitution u equals v squared plus 1. From that I got this solution. So for this solution, v is back substituted by the capital Y and capital X. So make sure you don't mix up simple and capital Y and X's. So and then we get the solution in capital Y and capital X forms, and again we need to back substitute for capital Y and capital X with the simple y and simple x terms, and then we get the final solution like this. So moving on to the second equation in the practice questions, we have dy by dx equals x minus 2y plus 3 and divided by 2x minus 4y plus 5. So thinking about this question actually cannot be done by the typical method of solving these non-homogeneous equations, which is by taking a capital X function for simple x and a capital Y function for simple y, because here look, we have x minus 2y in the numerator and 2x minus 4y in the denominator. So which is the denominator? Ignoring these parts, numeral parts, we have the denominator is 2 times of the numerator. So when we take these substitutions, we might get a wrong answer because these get cancelled out. So we need to take another substitution like this. So I'm taking another substitution. Let v equals x minus 2y. So by differentiating this, we get dv by dx equals 1 minus 2 dy by dx. So here we can write this equation dy by dx equals x minus 2y plus 3 2x minus 2y plus 5. So here we can clearly see x minus 2y terms which can be substituted from v, and dy by dx can be substituted here. So here dy by dx is 1 over 2 1 minus dv over dx. So here we can substitute this half times 1 minus dv over dx equals v plus 3 over 2v plus 5. So here by analyzing this, we can solve dv over dx equals, we get so here we get minus half, so this half can be taken to the other side, minus 2v minus so we can multiply this half into the other side first of all, so it might be easy. 2v plus 6 2v plus 5, and then we get dv by dx equals 2v plus 6 minus 2v minus 5 over 2v plus 5. So here 2v to 2v cancel out, so here is still minus dv over dx equals 1 over 2v plus 5. So now separating the variables, we get 2v plus 5 dv equals, so we'll just shift this minus sign to the other side, minus 1 dx. So simply now we can take the integral of the both sides. We get v squared over 2 plus 5v equals minus x plus c, where c is an arbitrary constant. So here we get v squared plus 5v equals minus x plus c, and back substituting for v, x minus 2y, x minus 2y squared plus 5x minus 2y equals minus x plus c. So here we can keep this equation as it is, like this, in the implicit form without taken into the explicit form. So here this the second question is a bit different from the first one because we didn't took the substitution in the capital X and capital Y forms. Instead, we took a different substitution like v equals x minus 2y. So when doing the question, we can think of how to choose these substitutions by looking at how these equations work. So hope you have a good understanding now about solving these non-homogeneous equations by reducing it to homogeneous forms. So stay tuned for more topics. Thank you.